Our next problem is with inefficient compute resources. With monolith, compute resources, mainly CPU and RAM, are divided across all components. We have a single process, the monolith, that consumes these resources and uses them for all its internal components. And this is not always the ideal case. For example, if a specific component needs more resources, there is no way to do that. We can't allocate more CPU or memory to a specific component that needs them. We will have to allocate more compute resources to the whole monolith, which will give them to all the components. And this is extremely inefficient. We will use more compute resources for components who don't need them, and the ones who do need them will get just a portion of these resources. So let's look again at our monolith. In our case, the process runs on a machine with 4 vCores, which is virtual cores, and 8 GB of RAM. Now, suddenly, this component requires more compute power due to intensive computations it was asked to perform. Our only choice with the monolith is to increase the compute power to the whole process and now make it, for example, 8 vCores and 16 GB RAM. Now, this increase will affect all the components inside the monolith, so the other components will get more resources, which they don't actually need, and the one that really requires it will get just a small portion of these resources. And this, as you can see, is a very inefficient use of compute resources.